All right, kids, here we go. It's time to talk about sea breezes, land breezes, mountain breezes, valley breezes. And I may or may not be picking on somebody just a little bit in this video without saying a word. I'll see if you can find out what I've done to maybe pick on somebody just a little bit. If you're not here, still got to pick on you because I miss you guys a bunch. But let's talk about sea breezes. Sea breezes are pretty easy. During the day, the sun heats up the land really, really hot. So let's take a look at that. So here it is. We're at the beach during the day, and the land gets very, very hot. Now, when things get hot, they start to give off heat. And when they give off heat, we have hot air that rises. Now, when I have hot air that rises, that means the molecules that were down here of hot air are all starting to get even further up here. So I have more molecules up here, which leaves down low a lower pressure. Okay, so we'll go ahead and type that in here. So I have low pressure down here, nodding blue. Pretty sure I had that in red, but maybe not. All right, so we have a low pressure here. Now, during the day, the ocean is soaking up heat. It's absorbing heat. It's reflecting a lot of heat. There's evaporation going on. There's a lot going on in the ocean. But typically during the day, and you know this because you've been to the beach and you've jumped into the water, the ocean is generally cooler. So the air above the ocean is cooler. And what happens when we have cool air? Well, we have cool air that sinks. And then there's that convection cell that we all know and love. And what happens now, this is probably going to type in red again, isn't it? I have a high pressure. And we'll just change the color of that super quickly. Boom, done. Now, we all know that wind likes to move from areas of high pressure to areas of low pressure. So what you're going to have happen is your wind is going to move in this general direction. It's going to move, I really would like to have done that in black. It's going to move from the sea to the land, and we name winds from where they blow, and it blows from the sea, so this is a sea breeze. And that's all described for us here on this slide. When it says in the day, when the sun is up, the land heats up very quickly, and the air above it warms up faster as well, and because of that, hot air rises. The warm air, and when it rises, it's less dense, it goes up, and that creates a low pressure. However, the pressure of the ocean is just the opposite. It's cooler and it drops, and when you have those two differences in pressure, we know that air likes to move from the area of high pressure to an area of low pressure. And we call this a sea breeze. If you've ever been out and tried to fly a kite, generally, typically, during the day when you're flying a kite at the beach, whether you're staying in one of the campgrounds, you're staying at a hotel, maybe even at a house on the beach, the kite typically blows towards the campground. It blows towards your hotel. It blows towards your house because the sea is blowing it away from the sea. It's blowing from the sea. The wind is blowing from the sea. So you have a sea breeze. That takes us to land breeze. Now, at night, it's completely different. You know, we spend all day tiptoeing over the hot sand during the day because it burns our feet. But when you walk on there at night, it's almost cold feeling. I mean, the sand is super cold. So we have something that's opposite going on at night. So let's take a look at that. Nighttime at the beach. Remember, the ocean has been kind of absorbing some heat, holding in heat, although it's been giving off heat all day long as well, and it's some evaporation. But now the ocean is typically warmer. So what happens is this. The warm air above the ocean starts to rise. And remember, I have molecules of air down here, but they're all starting to go up into the sky. Okay, so that leaves an area of low pressure. Man, this thing does not like me, does it? 2 S's, Mr. B. There's an area of low pressure over here. Changed it? Yes, we did. Now, over the land, because it's cooled off, and you know that from your feet, it's not as hot. The air's not heating up as quickly, and therefore at nighttime, the air over the land is cooler, and the air over the land starts to sink. And this is going to write in red again, isn't it? It's really going to make me mad. But it's all right. So we have an area of high pressure. Boy, this thing is not liking, but it's all right. We'll go back, change that to blue, boom. Now, as we've mentioned, wind moves from areas of high pressure to low pressure. So now it's blowing from the land to the sea. And that's how we have our land breeze, which is what we just covered on the last slide. We have a land breeze. And that's pretty easy to understand. And the questions about that are pretty simple, and I'm sure we'll review those when we get to that time. I'm going to skip this slide. I'm going to come back to it. I would have flipped those around, but that would have deleted all of your codes. I'm going to come back to valley breezes. It's really weird. But I do want to talk about mountain breezes. Mountain breezes. At nighttime, obviously down at the foot of the mountain, it's going to be a little warmer. I mean, a little warmer than it is on the top of the mountain, and we know that because everything, the land formations have been cooling off. So this part is actually kind of easy. It's a little warmer now that the sun has gone down low than it is on top of the mountain, and that's pretty typical. But here's what happens: because you have this area of warmer air, okay, warmer air at the mountain floor, and you have this cooler air up here, we know that what? Cold air sinks. So it sinks down from the mountain to the valley, and we call that a mountain breeze. And it looks a little bit like this. It's a little bit bigger picture of that, okay? So you have that cooler air up here, right? We know that it's more dense. There's all those heavy molecules. They're pushing and forcing their way down the mountain to where there's a little bit warmer air in the valley below. And we call that a mountain breeze. And I think that that's pretty understandable because we know that some of this hot air here or warmer air is going to be going up at night. And that brings us over here where we've got some kind of cooler air going down. And we have that convection cell that we're all very used to seeing. And it works out very well. And if you've ever been in a valley at night, you can feel that mountain breeze. And you have to be very careful if you're out camping. You don't want to get too cool from the mountain. But that's something that'll work out. But I do want to take a look at this last one. And it'll be on the test. They're not going to ask you to describe it thoroughly in depth, but I do want you to know about it because it's very, very different than any of the others, and it doesn't work the way you think it should because you're kind of used to seeing one thing. This does something very, very different. So that's why I wanted to save that one until last. So I'm going to go backwards if I'm not mistaken. I want to talk about valley breezes. Now, excuse me, just looking at the picture, I'm already seeing something that I'm not used to. I'm seeing some cold air moving upwards. But we need to talk about why that happens. So during the day, the air above the mountain is going to heat up faster than the valley down below. Some of that is because of like the shadow that the mountain casts. And just some of the heat's going to reach the top of the mountain first and foremost. When it does that, this warm air is going to move up, but that creates a low pressure system. And this cooler air down here, because of the way wind moves and air moves, it really doesn't have a choice. It's cooler. It's been cooled off. And so it says, hey, I kind of have to move up the mountain because I move from areas of high pressure to low pressure. If there's a low pressure here, it's going to move up. Think back to the balloon. It doesn't matter if I hold it like this, if I hold it like this, if I hold it to the side, or if I hold it to this side. Not much left in there, but it doesn't matter where I hold it. Whichever way I hold this balloon, even if I hold it like this, the air is still coming up this way because it's moving from an area of high pressure to an area of low pressure. So let's take a little closer look at that. Understand that warm air along the mountain slope starts to heat up, right? So we have this hot air that's not cold air, Mr. B. Hot air, click the red, there we go. Hot air is rising. It causes a low pressure system here. Because the air down here is a little cooler, it pulls this cool air up the mountain, and we call that a valley breeze. Why do we call it a valley breeze? Because it's coming from the valley. Now again, I don't want you to stress out too much about about valley breeze and mountain breeze. There's questions on the test, but that's about it. It's do you understand them? Do you understand where they come from? It's sea breeze and land breeze that are the big ones. So those are the two that I really, really need you to understand. But I'm not going to not talk to you about valley breeze. I'm going to not, and mountain breeze because they're very important and they are things that we will most definitely cover. Again, if you have questions, leave them on the Google Classroom. Try to leave out all the other comments so that it's easier and faster for me to answer actual questions. I love the fact that some of you have helped each other out. That's perfect. Please keep helping each other out. You know that I love that. And I will see you again on the next video.